So when we talk about probability, it's good to understand the difference between a theoretical probability and an experimental probability. And basically, a theoretical probability is a probability based on sample space, what we call sample space, or of the number of outcomes that we can count. Okay, and this is done without actually doing anything. Whereas experimental probability is slightly different in that we actually have to do an experiment. Okay, so for example, flipping heads, we can say that the theoretical probability of flipping heads is there's one heads out of two possibilities. So this is our sample space. One sample space that's positive, two sample spaces that represent the possibilities. So this is what we call theoretical probability. Now, this is versus experimental probability. When experimental probability for a coin flip would be actually flipping coins. We actually flip a bunch of coins and see what the ratio of heads to tails is. So if we just did it once, obviously we get a heads, we can't say that it's 100% heads. So experimental probability is based on doing some number of outcomes. And in fact, the more outcomes that you try, the more certain that you can be that your experimental probability is actually reflecting the true probability. So when we did the coin flip activity, you should have been able to see that that's an experimental probability. And when you actually flip coins, and you had a kind of a table like this, and you had the probability in the middle, and it kind of went like this. Probability kind of jumped up and down, but as you did a whole bunch more, it kind of focused in the middle, which is a true probability. Okay, so as we do more experiments, our ratio of, our probability ratio starts to reflect more like the theoretical probability or the true probability of this outcome. Okay, so this is something called the law of large numbers. So when we do this over and over again, the more often we do this, the probability ratio will more closely reflect the true probability. So we want to be able to, if we do any kind of experimental probability, we don't want to do too small of a sample. Okay, if we did, coin flip and did 5 coin flips, that's a very small sample. We will probably get very inaccurate results what the true probability is. However, if we did like 100 coin flips, that would be a lot of coin flips, and that would give us a much closer ratio to the true probability, which would in this case be 50%. So this issue of large numbers, law of large numbers, is an important issue when we're doing experimental probability. It has no effect on theoretical probability, but it's important with experimental probability. So the link to the video is here, so watch the video and then you can move on to the next part of the notes.